A glass capillary tube of internal radius r is equal to 0.25 millimeters is immersed in water. The top end of the tube is projected by 2 centimeters above the surface of the water. At what angle does the liquid meet the tube? Surface tension of water is 0.7 newtons per meter. We have a capillary tube and we know that the natural angle of contact between glass and water is 0 degrees. So the water might form a meniscus with an angle of contact of 0 degrees and rise to some height h, or if the required height h for a 0 degree angle of contact is more than 2 centimeters, then we would have a case in which water would reach up to the top of the capillary tube but then form a non-zero angle of contact. In either case, we have a formula that is weight of the water column, which is equal to volume into density, pi r square. H is the volume, rho is the density, and g is the acceleration due to gravity. So this is the weight of the water column would be equal to the force due to surface tension, which would be the contact line length 2 pi r in this case into the surface tension into cos theta. Why cos theta? Because if we look at this second figure here, the surface tension force would act along this direction, but only this component of the force is actually lifting the water up against gravity, and the angle between those two lines is equal to theta. Hence, we take the cos theta component, which is lifting the weight of the water column against gravity. Let us assume theta is equal to 0 degrees. Then we have h is equal to 2 pi r sigma divided by pi r square rho g. So pi and r cancel. We have height to be equal to 2 into sigma divided by radius into density into acceleration due to gravity. And we have everything in SI units here. So in the numerator we have 1.4 and the denominator we have 1 by 4 into 10, which is 5.6 by 10 or 0.56 meters. That is 56 centimeters, which is much larger than the 2 centimeters that is given in the question, and therefore this cannot be the case. So now we know that theta is not equal to 0 degrees and height must be equal to 2 centimeters. Why? Because if the height is lower than 2 centimeters, then it would still be pulled up, as angle of contact would be 0 degrees. At the edge of the capillary tube, however, the angle need not be equal to 0 degrees. So now, if height is 2 centimeters, we need to figure out what is cos theta. Cos theta is equal to pi r square h rho g divided by 2 pi r sigma. Again, pi and r can cancel out, and we have 2 into 10 to the power minus 2 meters, which is height, into 0.25 into 10 to the power minus 3, which is radius, 10 to the power 3, which is density, into 10, which is acceleration due to gravity, divided by 2 into 0.7, where 0.7 is a surface tension. So evaluating this, cancel out the 2 here, 10 to the 3, 10 to the minus 3. This is equal to 0.25 divided by 7. And this we can see is very close to 0. Therefore, theta must be very close to 90 degrees. And out of the options, option A is the one that is closest to the answer.